mathematics is about logic, and we use logic to establish mathematical truth. And how do we establish mathematical truth? Well, we use something called a proof. We will look at proof later. Proof, by the way, is a sequence of sentences which we either accept it to be true or derive from previous statement which is accepted to be true or is actually true. Alright? And in mathematics, when we have an equation like or a statement say 1 plus 1 is equal to 2, that is a proposition. That's a proposition. A proposition is a sentence that is either true or false. Obviously, we know 1 plus 1 is equal to 2, right? So that's accepted. So one item plus one item is equal to 2 items, right? So that is true. So any proposition, any sentence that is either true or false is called a proposition. And proposition can be written in many ways. For example, right? 1 plus 1 is 2. This is a proposition. Usually we denote a proposition using a small alphabet like this. P, right, is a proposition that says 1 plus 1 is equal to 2, for example. Or P is another statement that says, for example, Ming is a student, for example. So this is the inverse of a proposition is denoted as, for example, P with is denoted like this, with a little symbol corner thing like. And in Japan, this is denoted as small p with a bar on top. Small p with a bar on top, right? But in this course, I will use this little symbol here, right, for inverse. For example, the inverse of, if p is not dot, you see, colon. If p is 1 plus 1 equal to 2, then the inverse will be 1 plus 1 is not equal to 2. Another example would be p, right? X is larger than 5, then the inverse will be x is smaller or equal to 5. Smaller or equal to 5, right? How about trying an exercise here? So exercise 1, right? I say if P, for example, say X is an even number, right? Can you write out its inverse? Right? Okay, if you've done, you may want to pause it while attempting this, and then once you're ready, play the video again. Right? The inverse is X is not an even number. If you have written X is X is odd, unfortunately that is incorrect, because X is an even number can be the inverse of that can be two possibilities. It could be it's actually an odd number, or it could be 0. Remember, 0 is neither odd nor even. So this is the proper inverse. And I can also link this with set. If I link this with set, right? If you allow, this big P, set big P, this is capital P, right? Capital P to be all the set, the set where it contains all the x's that make this statement true, that is in P. Okay. Then the inverse is represented by P dash, right? P dash is the inverse. So P dash consists of all the elements or all the x's that make this statement P dash correct. Alright, this is capital P. Alright, this is small p, this is capital P. So this is to link logic with set. Alright, let's look at some other example. Alright, so here, maybe instead of you can also use this as an exercise as well. So let's say exercise 2. Alright, write the inverse for P, right, x is smaller or equal to 2, right? This is small p, right? You may want to try this out first by pausing the video, and then once you're ready, check the answer again by playing the loop. So the inverse of this is p dash. It's just going to be p dash x is larger, similar to this one, larger than 2. If you draw a dot, you can draw a real number line like this, x. Initially, I have 2. I have something like this. Right, like this. And this is my p, capital P. P represent all the x such that x is less than or equal to 2. So we have a black dot there. And the inverse of that is this open circle is in the opposite direction. This is my capital P dash. This represents all the x such that x is larger than